Well, happy Friday, my algebra students. Let's go over our Chapter 3 study guide solution so that we can be successful on our test on Monday and Tuesday. A day, you will have it on Monday, and B day, you will have it on Tuesday. So on number 1, we see that we are plotting the point -2, 4. So we're going to go ahead and go over to the left on the x-axis, -2, and up 4. We put our point and we label it. Then we're going to go ahead and plot our second point of 3, 5. That's 3 on the x-axis and up to 5 on the y-axis, solving for our labeling and putting our point of 3, 5 as B. And number 2, we get to have this set of points, and we're saying what the domain is, and the domain is the x values. So we don't need to repeat them. We can just say them once, so we know it's 1, 2, 3, and 6. The y values, or the range, are just 1, 2, and 5. And is this a function? And we can say, no, it is not. And because we can see that x repeats, or we could also see that if we were to sketch it out, we can see that it's not linear. We can also see that it's an x value cannot have more than one y value. So we know that we have some cheating going on there. All right. On number 3, we have a situation, and we need to find out which situation is represented in the graph. So when we look at the graph, the temperature is rising over time, and it is rising at the beginning, so it's increasing. So increasing is either A or D, and the other two says it's constant or decreasing, so we know those do not work. Then we can see that it stays the same, so we know D is probably what we're going to go for because it stays the same. And then we can also see that it rises rapidly, so we know definitely D is our correct answer. On number 4 is a multiple choice question that we have to decide what is the domain. How is the domain represented here? Well, we can see that the greatest domain, the x value, it can go to 2, right? And it can go to -4. So this is why we learned compound inequalities, because we can see it can be -4 or bigger than -4, and it can be 2 or less than 2. So A is our correct answer. On number 5, we're looking at the range, or the y values here, and we see that the y values are represented in the set of 0, 5, 6, and 7, or letter B. Just really solidifying what is a domain, what is a range, and looking at how to represent those. On number 6, we have some options for this function, and we look to the table on the right. We see that it's added consecutively by 4. Therefore, we know that the x value is multiplied by 4. So we're looking for one of these functions that's multiplied by 4. We can see letter B is the only one multiplied by 4, but let's check it and make sure that's correct. If I multiply the first x value by 4, I get 1 times 4 is 4, and to get to 8, I add 4. And that's exactly what it says to do on letter B. So I could check it again. I'm going to check it with the last one, which is 4 times 5 is 20, and plus 4 is 24. So yes, I know B is the correct function for these values in the table. On number 7, it gives us a function and says to solve for this function when x is 4. So we want to find that, and then we're going to see that when when x is 4, y is going to be 23. And we solve when it's -5, y is going to be -31. We do want to write them in the form of a point, so an x and y coordinate, because that is the solution. Number 8, we are seeing what is the dependent variable. When we talk about range and domain, domain is independent. It's dominant. It determines the y, right? And the y value is dependent on the x value. So when we look at the dependent variable of soda selling for $1.50 per bottle, we know that how much we spend will depend on the total cost of the bottle. So how many bottles of soda we buy will determine how much we pay, right? So when I look at this, y is always the money, and how much I spend on that is dependent on how many things I am buying. Number 9 gives us a situation where Joey is saving some money, and he's going to save some more per week. The first part of this says to write a function to represent Joey's situation. And we have to do this by writing a function like f of x equals 75x plus $200, right? The second half of this question says solve what he has after 8 weeks, or when x is 8, right? The function at 8. So that's 8 times 75 plus 200 is going to be $800. You must use a function to solve for this question, or it will be considered that you're not showing your work correctly, right? You might be able to logically reason it out, but I'm not asking you to logically reason it. I'm asking you to write a function, because chapter 3 is about functions. All right, let's look at our next question here. We have a scenario where we have different tables, actually just a table that can seat 14 people at a convention center. If we take out the chair and push the tables together, it can hold 26 people. So if we keep pulling out a chair and adding one more, we know that every time we do that, it goes up by 12, right? So our first question is finish the table. So if the first one has 14, then 2 tables is 26, 3 tables is 38, 4 tables is 50, and 5 tables is 62. Question 11 says use this information to write a function, right? Well, if it's going up by 12, we know we're multiplying by 12, right? But 12 times 1 is 12. To get to 14, we have to add 2, right? So let me just highlight this on here for you. If I'm multiplying here by 12, I still have to get to 14. So I have to add or subtract something to find the y value. In this case, I'm adding 2. Then on number 12, we're going to use this function. We need to use the function to solve for this question. It says the maximum amount of tables that can be joined together is 11, right? So if x is 11, will there be enough to seat 133 people? So we're going to use the function to solve for this, right? 12 times 11 plus 2, it gives us 134 seats, right? We only need to seat, will there be enough seats for 133? Well, the answer is, of course, yes. Yes, with one left over, right? We even get an extra. All right, and I added some extra word problems on here because these functions are so important that we learn. So on this scenario, we're given toothpicks making a shape, and we need to see the pattern, right? So we have to count the toothpicks. We see there's 6, and then it goes to 9, and then it goes to 12. So we write in our words, what is it changing by? Well, we can see that it starts with 6 pieces, but then everything adds every single step, right? At every step it adds by 3. We can use this information to fill out a table, right? And we can continue the table because we keep adding 3 consecutively. And if I'm adding 3 consecutively, I can actually write the rule or the function because I'm adding 3 consecutively, I'm multiplying by 3. 3 times 1 is 3. To get to 6, I have to add 3, right? And I can check it later on at 5. If I check it on this value right here, 5 times 3 is 15, and plus 3 is 18, so I know I'm doing it right. we take that information and we go ahead and graph it, right? So I have steps and I have toothpicks, and with each step, I'm just going to go ahead and graph my function. And you can see that even though, I'm just going to use a highlighter to show you this, that, use a highlighter real quick to show you that it is making a linear equation, but you can see how it makes a line, right? You can see that. Okay. And we're going to go ahead and do another practice one of these. In this case, we have these interesting tables with 6 chairs around them. So the first table can seat 6 students. And if we take a chair out in the middle and push 2 tables together, it can seat 10. And when we have 3, it can do 14 and 4. And you have to solve for that, right? Obviously, it's 18 because you're just adding 4 more, but you can count it up if you'd like, and it's going to fit 18 students on this one. And we can finish our table because we just keep adding 4 every time. And because I see this pattern again, the same situation, I'm adding 4 consecutively. So that means I'm multiplying by 4, so I can make a function 4 times the x values plus 2 to get to 6. Right? From here, just write my table again to remind you how we solve for this. I can go ahead and graph this situation. Now, these are all discrete graphs because I want to make sure that I am not doing partial seats, right? If this was a line graph, then I could have solutions in between, like if I'm draining a water tank or something, or filling up a water tank. So the question number 3 says Sarah has 47 students that can sit around, says that 47 students can sit around 11 desks. Is that true? Without having to draw it out. And so use the function plugging in 11. 11 times 4 is 44 plus 2 is 46, right? So Sarah's not correct, right? She's not correct because she's 1 short. And that's how we prove it.
High school 5-minute warning bell. Please head to class.
Okay, I gotta wrap this up because we're finishing up lunch here. So remember to bring this completed and corrected study guide. You can do it in pencil, but correct it in pen so it reminds you what to study to class, along with your 3-4 1 through 12 textbook homework. If you didn't do the graphing, and show it to me, or if you made mistakes, make sure you bring that with it. On Monday for A days and Tuesday for B days. And of course, do not forget that Sunday night, 7 to 8 p.m., we'll have a Zoom study session to ask any other questions that you might have or say hello to a friend. And then the link is on Learn. You can always email me or ask any questions. Don't forget the Mathematical Girl channel. Hit the video part and you can watch anything from the whole entire chapter or the year. Have a great day. Bye.